You'd think that when a powerful AI solves a math problem no human has cracked in 50 years, it just thinks really hard and prints out the answer. One giant brain. One brilliant guess. Done. That's not what happened. What Google DeepMind actually built, in a paper called AlphaEvolve, works nothing like that. It doesn't think its way to answers. It evolves them the same way finches evolve beaks, or bacteria evolve resistance. And once you see how it works, you realize we may have quietly entered a new era of scientific discovery. Here's the setup. AlphaEvolve is what the researchers call a coding agent. You hand it a problem, a math puzzle, a computer chip design, a scheduling job, and it starts writing tiny computer programs that try to solve it. Not one program. Thousands. Then hundreds of thousands. The loop has 4 parts, and this is where it gets interesting. First, there's a program database, basically a memory of every attempt so far, ranked by how well it did. Second, a prompt sampler grabs a few of those past attempts and shows them to the AI, saying, here's what we've tried, do better. Third, 2 versions of Google's Gemini model, a fast one and a smart one, suggest small edits to the code. And fourth, and this is the important one, an evaluator runs the new program and gives it a score. Good scores survive. Bad scores die. Sound familiar? It should. That's evolution. Mutation, selection, repeat. Now here's the twist most people miss. The clever part of AlphaEvolve isn't the language model. Everyone assumes the smart bit is Gemini generating ideas. It isn't. Gemini generates thousands of guesses, and most of them are wrong or useless. The real genius is the evaluator, the strict, unforgiving judge that only lets mathematically correct improvements through. The AI is allowed to be wrong constantly, as long as the survivors are real. Which brings us to the moment that made mathematicians pay attention. In 1969, a researcher named Volker Strassen found a way to multiply 2 4x4 matrices using 49 small multiplications instead of the obvious 64. That record stood for 56 years. Nobody could beat it. Then, in 2025, AlphaEvolve did finding a method that uses only 48. It sounds like a tiny improvement. It isn't. Matrix multiplication is the beating heart of every neural network on Earth. Shaving off even one multiplication ripples through billions of calculations. And it didn't stop there. AlphaEvolve pushed the boundary on the kissing number problem in 11 dimensions, squeezing 593 spheres around a central sphere where the previous best was 592. It improved records on more than a dozen other open problems in geometry and number theory. But here's the part that shows how quietly powerful this really is. The same system was pointed inward, at Google itself. It found a new scheduling rule for Google's data centers that recovered roughly 0.7% of the entire company's computing power that was previously just wasted. It sped up the training kernels for Gemini by an average of 23%, cutting Gemini's total training time by around 1%. It even rewrote a tiny piece of the Verilog code inside Google's TPU chips, removing bits that weren't needed. So return to where we started. You might think an AI solves problems by being smarter than us. AlphaEvolve suggests something stranger and honestly, more exciting. It doesn't need to be smarter. It needs to be tireless to guess, fail, and mutate faster than any human team ever could, while a patient judge keeps only what actually works. That's the real revelation. AlphaEvolve isn't a thinking machine. It's a survival-of-the-fittest machine, and the thing evolving inside it is human knowledge itself.